Hello students, this is FAZAL Wahab, and today we are continuing our main topic is the scalar and vector quantities. In today's topic we will be discussing the resultant, how to find out the resultant vector of two vectors, vector A and B. But before continuing this topic, if you are still not the subscribers, please subscribe the channel and click the bell icon to get the latest update, the notification for the latest update. So let's going towards the topic. So we have two vectors. Let's say this vector is vector A and this vector is vector B. And let me draw this one separately. This is, let's say this is vector A and this is another vector which is vector B, and we are going to add both of these vectors. So by head to tail rule, we have to join the tail of the first vector, which is A, to the head of the last one, which is vector B. So this one is the resultant vector is in this case, okay. So this is vector A, and vector B is making an angle of theta with the vector B, okay. So we will need this angle. We will need this angle when we will apply the law of cosine. So we will need this angle. So this angle will become 180 minus theta. Why? Because this one is a straight angle. This whole is a straight angle, and straight angle is always equal to 180 degree. So to find this one, so subtract this theta from this whole 180 degree. So we will get this angle, okay. 180 minus this angle, you will get 180 minus theta. So we will need this angle for the addition of these two vectors. So this angle will become 180 minus theta, and this will be the resultant vector here. This will be the resultant vector here. You can do this by applying the second option. If you want to put the vector B in the first place and vector A on the second place, so you can add both of the vectors with the same resultant vector. But before proceeding, we need to understand the law of cosine, because law of cosine will be used here. So we need first to the law of cosine, okay. So law of cosine, let's say you have a triangle. Let's say this is a triangle and here is the same triangle. We will take the same triangle. It's a triangle, okay, and this is A, this is B, this is C. A, so we will label this one is A, and this side is B, and this side is C, and this is angle, okay, this is angle A, this is angle B, and this is angle C. Okay, we can write the law of cosine in three ways. One way is this one. If we need to find out the angle B, the side B, for example, so side C and side A must be given here. Side A, side C, and the angle which joining these A and C, this must be given here. For example, for B, C, A, and angle B must be given here. Or for a side C, side B and C and angle A must be given here. If we want to side C, so side B and angle C must be given here, okay. So let's say we need to find out A. So A square will be equal to B square plus C square minus 2BC cos A. This is the law. A square, this side square is equal to this square plus this square minus 2 this cos this, means B square plus C square, B square plus C square minus 2BC cos A. This is the law of cosine. And the second way we can write this one, if we need B, side B, So b square is equal to a square plus c square minus 2ac cos b. If you need b square, so a square for b, we must need a, c and this angle. Okay, so b square is equal to a square plus c square minus 2ac cos b, minus 2ac cos b. And if we need the side c, c square is equal to a square plus b square minus 2ab cos c. A square plus b square minus 2ab cos b. So this is the law of cosine. This law of cosine is used for the solution of triangle. There are different things that is used for the solution of triangle. One is law of cosine. The second is sine rule or law of sine, which we will discuss this later. And also the trigonometric ratios can be used for the solution of triangle. If you want the solution of triangle, means you need to find out all the three angles, you need to find out all the three sides. So some of the things will be given here, and the remaining thing you have to use law of cosine, law of sine, and the trigonometric ratios, and then you can find out the values of all the three sides and all of the three angles. This is used. So in this case, this is also sort of triangle. This is a triangle, and vector A and vector B making an angle of 180 minus theta with each other, and R is the resultant vector. So these three vectors, which is A, B, and the resultant vector, making a triangle. Okay, so we have to find out the resultant vector here by using law of sine. So first, in order to find out the resultant vector, you need to understand law of cosine, because this law will be applied here. So now look at this. For example, we need the resultant vector. So the magnitude of the resultant vector, r square, is equal to a square. We will use the magnitude a square plus b square plus a square plus b square minus 2ab cos, and this angle is you can write this angle is r. You can write this one, or you can write this angle is 180 minus theta. 180 minus theta. We have already done this one. Okay, so r square is equal to a square plus b square minus 2ab cos 180 minus theta, or r square is equal to a square plus b square minus 2ab cos 180 minus theta is equal to minus theta. This will become minus theta. Minus theta. Okay, so r square is equal to a square plus b square minus plus 2ab cos theta. Cos theta, this one. Okay, so this is, and you need r, so a square plus b square minus 2ab cos theta minus, not minus, plus, and under root. To remove this square, so we will take the square root of both sides, and we will get a square plus b square plus 2ab cos theta. This will be the final resultant vector, the magnitude of the resultant vector, because we need to find out the resultant of the magnitude of the resultant vector. So we will use the magnitude of vector A, we will use the magnitude of vector B, and we will get the magnitude of the resultant vector, which will be this one, a square plus b square plus 2ab cos theta under root. This will be the magnitude of the resultant vector. Okay, I took this option, and you can use the same option here. So you will you can find out if you want to use this triangle, so you will get the same result. But we took this triangle, and we will get the resultant with the magnitude of the resultant vector, this one. So this, it's the same if you want to use this one, either this one or this one, result will be same. Okay, the next thing that we will discuss is the law of sine, and where is the law of sine will be used here in this case. So if we need to find out the direction of this resultant vector, for example, this resultant vector making an angle pi with the x-axis or with the vector A. So how can we find out the resultant of this vector? Okay, let me label this one, this triangle. This is, this is A, let's say this is B, and this is, let this one is C. Okay, so if we need to find out this angle, what angle or resultant vector can make with the triangle A, if we need to find out this one, we will use the law of sine. And what is the law of sine? Okay, it's not mentioned and it's not part of the syllabus to derive the law of sine or to derive the law of cosine. This thing has been mentioned in the mathematics, in the first year mathematics, in chapter number 11, chapter number 10. But in physics, it's not the part of the syllabus to derive law of sine and law of cosine. So you need just to understand what is law of sine and to use it in the for the law of sine for the angle, for the direction of the resultant vector, and law of cosine for the resultant, the magnitude of the resultant vector. Okay, so here's law of sine. If a triangle has been given here, let's say this is a triangle, this is a triangle, and it is A. Let me write, this one is A, this one is B, and this one is C. And A, this one is A, B, this side is B, and the length of this side is C. Okay, small letters. So law of sine is A upon sine A upon sine A is equal to B upon sine B is equal to C upon sine C. Okay, this is the law of sines. A upon sine A is equal to B upon sine B. One angle in opposite side to that angle makes one pair. Mean this is angle A, and opposite side to this angle is side A or BC. So this makes one pair. Okay, and angle C and opposite to this angle is side C or AB. This makes another pair, and angle B and opposite side to this angle is side B. This makes another pair. So A upon sine A is equal to B upon sine B is equal to C upon sine C. And this is also used, as I have already mentioned this one, that this is already used for the solution of the triangle. If you wanted to find out the solution of the triangle in any angle, okay, so in this case, we can take this pair, we can take this pair, or we can take this one. Okay, so three pairs can be used for the solution of this triangle. For example, angle A and side A has been given here, side B has been given here. You can find out the angle B. A upon sine A, this has been mentioned, this has been mentioned, B is mentioned, so angle B can be find out. So in these four things, side A, angle A, side B, angle B, you can use the three values to find out the fourth one. In this pair here, in this case, you can, if you have the value of B, angle B, C, angle C, so you can find out if any one of these four things is missing, you can find out that the fourth one. Okay, so this law is used for the anything which is missing. So you can use these ratios and to find out the missing thing here. Okay, so for example, if I needed, let's say this one, this angle I needed, so A upon sine A, I will take this one, sine A is equal to B upon sine B, B upon sine B. Now apply the same rule on this triangle. Okay, so I think we need to remove this one, we don't need this one. And here is this side is b, the magnitude of this side is b. It is a vector b, but the magnitude is b. So b upon sine this angle is pi. Pi is equal to r, the magnitude of the vector r is r upon sine 180 minus theta. Okay, now we need this pi, the angle this pi, the resultant vector makes with the vector a. So we need this angle which is pi. So now cross multiply this one. So r sine pi is equal to b multiplied by sine 180 minus theta. 180 minus theta. Okay, we need the pi. So sine pi is equal to b multiplied by sine 180 minus theta and divided by r. R is multiplying with sine pi. This will become divided here. Now pi is equal to angle pi is equal to sine will become inverse here. Sine inverse b multiplied by, okay, sine 180 minus theta is equal to sine theta. Sine 180 minus theta is equal to sine theta divided by r. Okay, how is sine 180 minus theta is equal to sine theta? Let me explain this one. Let me derive this one here. We have formula, and you will learn this in the mathematics, class 11 mathematics, chapter number 10, is sine alpha minus beta. This is a formula is equal to sine alpha cos beta minus cos alpha sin beta. It's a formula. Okay, sine alpha, now here in this case is sine 180 minus theta, sine 180 cos theta, because sine 180 alpha is equal to 180, beta is equal to theta. So sine 180 cos theta, because theta is used for beta here. So cos sine 180 cos beta cos theta minus cos 180, which is cos alpha, sin beta, sin theta. So sin 180 is equal to 0 multiplied by cos theta minus cos 180 is equal to minus 1 multiplied by sin theta. This will become 0, minus minus plus 1 multiplied by sin theta. You got only sin theta. Okay, so sine 180 minus theta is equal to sin theta. That's why I put the value for sine 180 minus theta is sin theta. Okay, so this is the final answer. To find out the angle or the direction of the resultant vector, we are using this sine rule. And what is law of sine? So we have explained this one. By using law of sine, we can find out the direction of the vector by using this whole method. Okay, so this is rough work. You don't need to mention this in the paper, but I just wanted to derive this. How is sine 180 minus theta is equal to sin theta? So I have shown this one on the blackboard, on this board, but you don't need to derive this one in the paper. You don't need this one.